Okay, so I think that will have started streaming now, hopefully. There's some, there's a few questions here. These are from Maths Genie mini tests. So it's a great place as well if you wanted to do some, relatively quick revision. They've got a smaller tests, obviously, it's what they're called mini tests. That's where these 4 questions are from. There's about, I think there's 8 to a page, double sided, about 16 questions of varying difficulty. And this is one of the foundation ones, just to get started, warmed up. Or if you are doing foundation, the questions that you'll be getting similar to on your test. So I'll give you a few seconds, well, not more than a few seconds, a few maybe minutes to have a go at those questions. Hopefully you can see them a bit better this week. And just while people are joining, have a think about those, what you would do. They're not supposed to be the most difficult questions, just to get us thinking this morning, first thing. So some fractions, probability, sequences, and then again, well, ratio and fractions. Okay. Hi Lewis, I'm doing good. Good to see you this morning. I'm all good. Hope you're well as well. Hope everything's going good. I'm sure it is. So, while you're doing that, while you're thinking about that, while people are joining, I'll just go through again, what we've got on the screen. So, got the countdown to the first paper. So if you have a look at that, that's 11 days. So that is not long really at all. I don't think that doesn't look like that's changing. Hopefully it is. Hopefully it is now. Yeah. So less than 12 days, just over 11 days. So that's, what is that? That's less than 2 weeks. So, it's basically 2 weeks, the Friday just gone. Quick maths. It's not a long time at all. I'm sure you all are already, but, make sure you're sticking to your timetables, or mention that again, because it's important. And at some points you will think, I can't be bothered, I don't want to do this. I want to just relax, I want to chill out. It's for a short period of time to get you through your GCSEs. To help you with those as much as possible, and it's what you said that you wanted to do. So, in a sense, look at it as you're not letting yourself down, because that's what you promised yourself you would do, or you said to yourself you would do. So, stick with that. It will make a difference, and it's it's not long to go. And once it's got started, you probably won't feel as frequently, at least, that you want to just have a break or anything else, because it's happening then. You're in the moment, and so it's very real. It is going to be happening, so you can't kind of put it off as if it's not going to happen. It will happen. Just do your best, like I know everybody that's watching will, and keep going with it. And now the other things on there, the exam grades. So we've got higher, foundation. They're the averages. I believe I took those from before last. Well, I might have included last year as well. But if you basically, what's probably going to happen with the exam grades is they're going to get closer to 2019, i.e. before COVID, than to 2021. They're going to be somewhere in the middle. They could be closer to 2019 and 2021, because what the exam boards are probably going to want to do is get the grades closer and closer to where they were before the pandemic. Obviously, after the pandemic, immediately after, because there's that disruption, they are different. So, the exam boards are going to try and, I imagine, get it closer back to those grades. So, in terms of a benchmark, I would probably aim for the 2019 ones and use them. Now, it's not going to be exactly 2019, so giving yourself a bit of leeway there, but that would be better than going off 2021, because if you go with 2021, they're going to be, you know, harsher than those. And so if you think, oh, I'm on this grade, on 2021 grades, then when it comes to actually the exam, you know, grade boundaries, you might not be on what you thought you were on. So it's better to underestimate than overestimate, if that makes sense. So there's a saying, plan for the worst, hope for the best kind of thing. So plan for 2019 grades before COVID, and hope for the best, and you know, hope for the best grade boundaries possible. And the other things, you know, do use this, the foundation and the higher tier weightings for the topics. So when you're doing your revision, you know, 30% of the higher paper is algebra. So you need to be confident and comfortable with your algebra. And if you're not, then you need to, you know, really address that area. And similarly, on the foundation paper, it's ratio, proportion, rates of change. So you know, obviously your ratio questions, proportion, direct, inverse proportion, rates of change, you know, currency, best value, problems, things like that. If you're not comfortable with, then also there's the number work. Number is a big part of it, especially towards the front of the paper. So you know, say you're aiming for, or say, well, if you want a grade 4, which obviously I imagine everybody wants at least a grade 4, then you need to be able to do all the number stuff at the front of the paper, and then obviously that will get you up to near enough halfway, and then you need to be able to be getting your rates of change, proportion and ratio questions as well. And then there will be some geometry, probability questions and algebra questions as well, but not as frequently. And then there's the recommended websites. You know, I'm finding more and more. I imagine there are lots of others that are very useful. What have I got on there? Maths Genie, Maths Bar, Congruent Maths, GCSE Maths questions, and MME Revised. So yeah, they're still probably the ones I would recommend as the top 5 for GCSE revision. Maths Genie to be the most user friendly, but you know, there are textbooks and everything else that you can use as well. And of course, you know, if you want to support the channel, there's that Buy Me a Coffee QR code in the bottom left hand corner, which you should be able to scan with your phone, or you can just click the link in the description, and that will take you to it. Okay, right, so I think it's been long enough, I've done enough talking, so I'll get started. This session this week is going to be on congruent triangles as well, which is one that somebody asked me to do. If there's things that you want me to do, please type in the chat, let me know, and I'll make sure to do that, to go through it. Okay, we are both in the 20 is in the 4 and 5 times table. That's the lowest common multiple, which is what we want. So to get a denominator of 20, I need to times the denominator by 5, so I need to times the top of the numerator by 5 as well. 3 times 5, 15. Still subtract, and then I need to get 20 as a denominator of this fraction, so I need to times by 4. 5 times 4 is 20. 1 times 4 is 4. And then if I subtract these, 15 take away 4 is 11 over 20. Then I need to think, can I simplify this? Well, there's no number, so there's no times tables or no number I can divide 11 and 20 by. 11 and 20 aren't in any times tables basically. There's no number I can divide both of them by, so that's as simple as it can be. Then what's called coprime, so there's no number you can divide both of them by, and yeah, that's then fully simplified. Next question. In a bag there are only red counters, blue counters and white counters. The counter is taken at random from the bag. Find the probability that the counter will be white. So we're looking at probabilities here. Now, probabilities usually are fractions or decimals. If it doesn't give you, decimals in the question, or doesn't ask for it as a decimal, I'd recommend using fractions. In this case, they have given us decimals. Also given us a table with a blank space, which that should help with your muscle memory of these type of questions, basically, because if you've got a table with a blank space, it's quite obvious that what you're going to do, or should be once you've done a few of these questions, these will all add up to 1. The total of all your options is all your probabilities added together, which will be 1. So if we do 1 take away 0.42 take away 0.3, that will give us the answer. 1 take away 0.42 take away 0.3 gives gives us 0.28. So that is the probability that the counter would be white. Now if I ask you to find the number that would be white from, let's say, 20 counters that are picked out and then replaced, you would do 20 times by 0.28, because you want that decimal, or that proportion, that fraction, if you change it to a fraction, of the 20. But that isn't the question. If it was, that's what you'd do. Okay, next one, sequences. Here are the first 5 terms of sequence. Find an expression in terms of n for the nth term. So that's kind of the trigger word that makes you think, I know what I'm doing now, this is nth term, because there's quite a few things they can ask you with sequences, you know, the next term, what's the rule for the sequence, the nth term, things like that. So it's important you read the question, you don't just see a sequence and just work out, say, one of those things. You've got to know what they want you to do. So nth term, so we've got to figure out whether it's going up or down by the same amount each time. So this is going down by 4, so minus 4, minus 4, minus 4. Okay, so what other sequence goes down by 4? Now, you could think about it like this, the minus 4 times table, or that this is the number that goes before the n. That's easier to think about logically when you're dealing with something that's going up by like 2s or 3s, because then you can think about the 2 times table or 3 times table. So this is less intuitive unless you know the method. So well, I'm going to write down the minus 4 times table, so it'll be minus 4, minus 8, minus 12, minus 16, minus 20, and then you've got to think, well actually that isn't the numbers, so what's the difference between the minus 4 times table and this sequence we've got, i.e. what do you have to add or take away. To get from minus 4 to 29 you'd have to add 33. Okay, so if I add 33 to each of these, we should get the same sequence. So negative 4 add 33 is 29, which is the same number. Negative 8 add 33 is 25. Now these should all be the same, because obviously this is going down by 4s. So I add 33 to them all. This sequence will also go down by 4s, which will give us this one. Okay, negative 12 add 33, 21, 17, 13. Then what we need to know is actually what's the nth term of the 4, or negative 4 times table, and that would be negative 4n, where n is the term. So negative 4 times 1, negative 4 times 2, negative 4 times 3, and so on. And then you add 33, so we get negative 4n plus 33 would give us this sequence, which is all we want, so that's the answer. Negative 4n plus 33. Okay. The next question is asking us, well, letting us know about, in April it rained on 3/5 of the days. Okay, so my first thought then, just reading that first line, is if it rains on 3/5 of the days, then on 2/5 of the days it's not going to rain. Okay, so I could just write that down. Not going to rain, or not raining 2/5 of the time. Okay, so I'll just remember about the headset again. I've left it over there. Move a bit closer, you can hear better. Probably was fine, but just to make sure. Write the ratio. The next bit, so ratio. And now we're changing fractions into a ratio, so that's a skill you've got to know how to do. Right, the ratio of the days it rained to the number of days it did not rain. Okay, so the ratio of raining to not raining, basically. So it rained on 3/5 of the days, 2/5 of the days it didn't rain. If we want to change these to a ratio, ratios compare parts to parts, whereas fractions compare parts to the whole. So comparing part to part, we've got 3 to 2, forgetting about the whole bit on the bottom. Okay. So days it rained, got to make sure we get this the right way around. Days it rained was 3 to 2, and that's it. Okay. The next bit, we're going to get started now on looking at congruent triangles. Okay, this is from Maths Genie. It's, if you go to resources, it is under tests, I believe. Yeah, there's also 45-minute tests as well, which you can do, which would be useful. And I know, I've done some of those in my classes as well previously, so you might want to look at those. And they've got predicted papers and stuff on there as well, all under resources. It's a great website. Okay. Right. This, basically, and this is from Dr. Frost Maths, which again is a brilliant place to get resources from. It's got whole lessons on there for things. This explains the basically 4 criteria that we need for 2 triangles to be congruent. So these are the 4 things you need to remember. So side, angle, side. Okay, 2 sides and the included angle. And you have to go in that order. So side, angle, side. Okay, so the angle is between the 2 sides. Those sides have to be the same, which you can see from these lines. Now these lines you should draw on to your diagrams of your questions. The next one, angle, side, angle. So if you've got 2 angles and a side, so you've got 2 angles and a side, and the reason that that works is because if these 2 angles are the same, then this third angle, if you do 180 take away those 2, will also be the same, and then you end up with angle, angle, side, angle, which is the way it works here. But if you've just got 2 angles and a side, that is fine, that will work. Okay, the next one is 3 sides. So if you've got 3 sides that are the same, then the triangles will be congruent. And if you've got a right angle that's the same, a right angle, pointed at the side, pointed at the hypotenuse. If you've got the right angle that's the same, the hypotenuse that's the same, and another side, then they will be congruent as well. Now, at this point, what I want to say is just explain what congruent means. If 2 shapes are congruent, then that means they're exactly the same shape. Exactly the same angles and exactly the same sides. Okay, it doesn't matter about the orientation, so the other triangle could be turned around, it might even be reflected, things like that. Okay, it doesn't matter about transformations, unless it's an enlargement. Because if you have 2 triangles which have exactly the same angles, that's not sufficient for being congruent, because you could have 2 shapes, one that has been enlarged, that are or have the same angles, but they have different length sides. So they're what's called similar but not congruent. Okay, congruent has to be exactly the same length sides and exactly the same angles. So, with that in mind, the reason that all of these 4 work is because if we look at this first one, for instance, if you have 2 sides and the angle in between, you can use the cosine rule to then show that this third side would also be the same. Okay? So that's why that works. Now, again, with the same token, 2 angles in a side. So if you've got 2 angles that are the same, the third angle must also be the same. Now, if you've got 3 angles that are the same and a side that is also the same, then what that means is, and they have to be obviously in the same place, so opposite that angle, okay, they say opposite the same angle basically. Then what that means is that that triangle, because it's got the same angles and the same corresponding side that's the same, the other corresponding sides by sine rule would also be the same. Okay, 3 sides that are the same. The 3 sides, corresponding sides, are the same, then the angles in between must be the same. Okay, and we know that because of the sine rule, because if you've got side over sine something is equal to, well, the opposite angle basically. So side over the opposite angle is equal to another side over the opposite angle. So those angles must be the same. Okay, that's the only way it's possible to make a triangle with 3 sides the same. With right angle, hypotenuse and another side, you can, because you've got a right angle there and you know the hypotenuse, what you can do is use Pythagoras to work out the other side. That must be the same. It has to be. Okay? It has to be the same. So then you've got 3 sides and an angle that are the same again. Okay. Now, what won't work is, well, one, like I've said, having 3 angles that are the same, but also if you have angle, side, side, so if you have this angle not in between, then you can't use the cosine rule, okay, to get your length side. There are 2 possible triangles with 2 sides the same. Okay, so you could have this triangle or you could have this triangle. Okay, so there's two possible ones, which means it can't be congruent. Okay, because you've got different options basically. So it's not sufficient for congruence. Now these are things you need to know and be aware of. The reason that that isn't sufficient for congruence, you might be thinking of the sine rule. Now, basically, because you would be doing reverse sine here, and you'd be doing reverse sine to work out an angle, there are two options for basically the inverse of sine. If you think about your sine graph, so I'll do a quick sketch, which is why you get the two triangles. So the sine curve goes like this, okay, and you've got 360 at this end, you've got 180 at this end, in the middle here 90, and the middle of here 270. It goes up to 1, down to negative 1. Now, let's say that you're doing inverse sine of some number, because you've got it all rearranged, haven't you? You know, sine rule is sine. A over A is equal to sine B over B. So if I want to work out, let's call that side A, you want to work out A, so you get sine A is equal to A times sine B over B, and you inverse sine that, obviously with your numbers in there. So inverse sine, A would be equal to inverse sine of this thing, whatever that number is. Okay, so the issue with this is I'm doing inverse sine of some number, so that number would be somewhere like negative or positive. Let's say it's here, let's say it's 0.5, okay? Now if it's 0.5, then what you'll get is you'll get one answer here, okay? You'll output one answer for that value of sine, but it will also have this other option over here, so it ends up having two values, which is why you end up with these two triangles. Okay, now that's not something you're expected to know or really to deal with at GCSE, but that's why it happens, and that's why you need the angle in between. Okay, because doing inverse sine, you can get, at least between 0 and 360, you can get two answers doing inverse sine. Now, if you do sine of an angle, so if you were to go up rather than across and down, if you were to go up, you only get one answer. Okay, you can't get multiple. Okay, and it's what's called let me think about this the right way. Is it? Well, actually, I'll get that mixed up, so I won't say that. But it's a certain type of function where you get basically many to one. That's the right way around. So a couple of answers will give you the same output, basically. Okay. So for instance, if you did sine 27, I can show you this actually. Sine 27. That should give me the answer, as because this should be symmetrical, sine of 180 go back minus 27, whatever that is. Okay, so we get the same thing. So that's why it doesn't work. Okay, anyway, that's an extension. You don't need to know that, but I just want to explain why. Okay, need to know these, remember these. Keep these to hand if you're practicing these questions, and maybe put these on flashcards so that you can learn them properly. These are the types of things I put on flashcards to help you remember them. Okay, let's keep these to hand. Now, looking at this question, hopefully you can see this well enough. I'll read the top bit. So it says, state whether the following pairs of triangles are congruent or not. Give reasons for your answers. If there is not enough information to make a decision, explain why. Okay, so we'll look at A first of all. Now, we've got vertically opposite angles here, so they have to be the same. Okay, that's normally indicated with a dot for the angles, which is what you'll see down here. They're the same, so what we've got is sides that are the same, angles that are the same. So what we've got is side, angle, side. So you could say, if you were to write your proof, BC is equal to CD, AC is equal to CE, and then you'd say side, and then angle, you've got BCA is equal to angle ECD. So therefore, that's what those three dots mean. Triangles BCA and ECD are congruent by side, angle, side. And that's all you need to write, really. So in terms of these explanations, they're a lot simpler than like angles and parallel lines and things like that. Okay. Next thing is to look at B. So, now, when I looked at this previously, I was thinking, really, is there enough information there? And I'm going to be a bit maybe pedantic or, a bit particular. What people would do and assume is that, and maybe it would, I would need to think about it a little bit more deeply, but actually I want to make the point here about actually using the information that is given to you rather than assuming. Okay? Now, it looks as if there should be a right angle here, and we've got an isosceles triangle, which means that these angles have to be the same, because the angles at the base of an isosceles triangle are equal. But I don't know for definite that this line is perpendicular to AD. I know it goes from that point to that point, but if it's just slightly off, then those triangles would not be congruent. And it doesn't have the angle on there that that's a right angle. So, what I would say is there's not enough information to know that BC is perpendicular to AD. So, there is not enough information because we don't have the fact that's a right angle. If you do, then you would have enough information. Not enough information, as we do not know that BC is perpendicular to AD. If you did, suppose we did, say that's right angles, we've then got a right angle, we've got a shared side, okay, we've got a shared angle, we're presuming those angles are the same, okay, shared side, we've got basically side, well we've got angle, hypotenuse and side, okay, right angle, hypotenuse, shared side, so then it would work. Now, you might be thinking, well we've got a shared side, we've got side, side, angle, okay, now that again doesn't necessarily mean it works, because if we go back here, if you've got side, side, angle with the angle not in between, that is this. Okay, side, side, angle. That would have two variations. So, yeah, you can't necessarily assume that that would work. Okay, that's not sufficient. Unless we've got that right angle there, then it is. And they might have meant that, they might have thought that we would assume that that's the case. Question C. We've got equal sides, we've got two sides that are the same, but we don't know that any angles are the same. So again, although they look like they would be congruent, I don't want to assume. Okay, we've got two sides, there's no way I can tell if those angles are the same or not. Okay, and as such, this could be very slightly wider than that, which means this side is very slightly longer. Okay, but those sides could still be the same. So not enough information. Should put not enough info because I've explained why. I don't need to write it all down again, but yeah, not enough information. And then this one, D. Now again, we've got vertically opposite, so those angles must be the same. But this is a bit more obvious. Look at the shape. This one on the left hand side looks bigger than this triangle, okay, and actually it says that these sides are equal and these sides are equal of the different triangles, so they would be similar triangles because you've got those sides, they're isosceles triangles with an angle that's the same in between. If that angle is the same, these angles must be the same here because angles at the base of an isosceles triangle are equal, so they'd be similar shapes, they wouldn't be congruent. So no. Okay, and then E, we have got angle that's the same, that's what the dot means, because, well, I don't know why they put a dot and they put angles here. I'm going to assume these angles are the same. If that is the case, you've got two angles that's the same in each of these triangles, so these third angles must also be the same. And we've got this shared side here, so AC is shared. So AC is a shared side, Angle, let's do DAC is equal to BAC. Angle ADC, the band. That's ACDC, isn't it? Excuse me. ABC. Like I said last week, when you're doing these letters, they always make you think of certain things for whatever reasons. BCA is equal to ACD. BCA, like the vitamins, I think. ACD. Okay. Therefore, triangles ABC and ADC are congruent by basically you've got angle side angle, haven't you? So you've got angle shared side angle. You don't have to do like a four-lettered one, angle, 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 side. You can just, because you've got those three angles, angle, side, angle. Okay, right. Those questions finished. Any questions, let me know, type it in the chat, okay? I presume I don't get many questions, I presume it's all okay. Unless you tell me otherwise. I don't imagine I'll get many questions in the chat. Right, these questions. So I'm going to go through basically some different types of questions. Ones which, you know, I think these are from the same exam board, and I believe it's, I want to say AQA. I could be wrong, but I believe these are from the same exam board. And it's not EdXL, it's definitely not EdXL. It's either AQA or OCR, and this is the certain type of question that they ask. So, two of these triangles are congruent. Write down the letters of these two triangles. So this is a nice question, because basically you've got to look at your sides and your angles, and they're giving you two angles in most of them. So if you work out the third angle, like this one, so that would be 55, well, 180, take 55, take 45, which is 80 degrees here, here 45 and 80, take that away from 180, and you get 55 degrees. Okay, now you can see I've got a side as well. I've got 10, 55, 45, 10, 55, 45, so angle, side, angle, so it's going to be A and D. If you look at the other one, there's not enough information, because that's 55, okay, and you've got 8 and 10, but that's side, side, angle, side, side, angle, so you can't be sure that they are the same, because that's the one where you could get two different variations. Next question. Here are four triangles. Which two triangles are congruent? So a very similar type of question. Now the ones with two angles in, you want to work out the third angle. That seems like a common thread with these questions. 180 take 25 take 56 is 99 degrees. And then I'll do this one. So 180 take away 25 take 56 gives 99. So they've got the same angles. That's good to know. Actually, they've all got the same sides, so this question will be about which angles are next to the 8 centimetres, because they've got to be the same angles, haven't they? So 180 take away 25 take 56, 99 again. Don't know why I keep doing this, and that's got to be 99 as well there. So if we look at this one, we've got 8 and then 25, 56. We've got 8, 25, 99, 8, 25, 56. So those two should be it. Because if we look at the other two, they've got 8 and 56, 99, 25, 99. They've got to have the same angles, obviously. Those, when it says angle, side, angle, it's got to be the same angles and the same side. So A and D again. Okay. Next questions. Excuse me. Circle the reason why these triangles are congruent. Now this is definitely from these three questions that are very similar style, multiple choice, are definitely from AQA. I know that because I've done through a few AQA papers recently, and I remember these types of questions coming up. So, they've told you they're congruent, you've got to identify the reason why. Now, as long as you know what these are, it's fairly obvious. So right angle, we don't have the hypotenuse. We've got an angle side and an angle. Angle side angle. So that's got to be this one. Next one, circle the reason why these triangles are congruent. So it tells you. You've got side, angle, side. Okay. So, and the angles in between, which by cosine rule would give you the other side. So side, angle, side. It's basically just knowing what the letters stand for at this point, isn't it? And then circle the reason why these triangles are congruent. Well, they've got all three sides that are the same, so they must have all three angles that are the same. So that's side, side, side. Okay, very straightforward, that type of question. Then we start to get on to some of the more interesting ones. So prove that these triangles are congruent. Okay. Now starting off with the first or the easier or possibly the easiest type of proof. I'll give you a second just while I have a drink of water to think about what you'd write. Okay. So got that side that's the same, we've got this side that is the same, and we've got the angle that is the same as well. And so you just need to write that down. So side GH is equal to side JK. I'm not joking about that. Side GI Joe is equal to side JL. Angle HGI is equal to angle KJL. Therefore, triangle HGI is congruent to triangle KJL by side angle side. And you can abbreviate that. On the mark schemes it does include those abbreviations. Next question. Now the next question is congruent triangles, but it's kind of hidden in the question. Okay, so it says ABCD is a quadrilateral, AB is equal to CD, so we've got that on there already. Angle ABC is equal to angle BCD, so they're the same. Prove that AC, so prove that A to C is equal to B to D. Now, you probably want to draw out these two separate triangles, because if I draw the lines on here, it could get a bit confusing. So that's AC, we've got to prove that that is equal to this. Now, you could do it, with that diagram that I've just drawn, but it might be a little bit complicated. So what I'm going to do is I'm going to draw two triangles. Okay, a bit smaller, obviously, because it's taking up a bit of space. And this is only a sketch anyway. And the other one is going to go this way. Again, look, this is not perfect. Those don't really look the same, I get that. But it actually doesn't matter. Now, basically, that side is the same as that side. This angle is the same as this angle. It says it's a quadrilateral, doesn't say it's a parallelogram or anything, trapezium. So we don't know that those are parallel. Prove that AC is equal to BD. Well, if I label this, that's A, B, C. This one would be B, C, D. That side has to be the same as that side because it's a shared side. Okay, so first thing to do is, well, now we've got it. Now we can see it's angle side. Side angle side. Okay, we just need to write it in the same way we've written this. So first thing, actually slightly different. BC is a shared side. Now, if it's a shared side, that means it has to be the same. Side AB is equal to side CD. You might want to write, given. That's given in the question. Angle
ABC is equal to angle BCD. Again, that's given. Therefore, triangle ABC is equal to, sorry, I should say is congruent, shouldn't I? Because that's what the question is asking. To triangle BCD by, what was it, side angle side, SAS. Okay, next question. That's done at that point, so that's all good. Next question. A and B are points on the circumference of a circle, centre O. CA and CB are tangents to the circle. Prove that triangle OAC is congruent, so OAC is congruent to triangle OBC. Right, now, this is involving circle theorems as well, so you need to know your circle theorems. A radius going from the centre to the edge, that's a radius, meets a tangent at 90 degrees. Now, OC is shared, but it's also the hypotenuse. There's actually quite a few ways you could do this. These have to be the same length because they're radii, that's plural for radius. OC is shared, so we've got right angle hypotenuse side straight away. But if you do use another one of your circle theorems, tangents to a circle that meet at a point are equal. So actually, and we know this anyway, because if we know it's congruent because of right angle hypotenuse side, we also know that that side's going to be the same. And that's kind of a way, well that is a way that you can prove that circle theorem, that, you know, tangents to a circle that meet at a point are equal because of this, because the two triangles are congruent. So kind of got two things there in one go. But they will be the same as well because of that circle theorem. But I'm going to use right angle hypotenuse and this radius side. So OC is a shared side. Side OA is equal to side OB. Both, I'm going to write both radii. So radii is like rad and two i's afterwards. And then angle OAC equals angle OBC equals 90 degrees, as a radius meets a tangent at 90 degrees. Okay, and then we've got everything we need to know. So we've got right angle hypotenuse side. Therefore, the triangles are congruent by right angle hypotenuse side. Done. And you can treat these like bullet points really. So you need 4 bullet points to answer these questions, these proof ones. Right, next question. Getting through these a bit quicker than the other weeks, which is good. I'm getting the timings a bit better. So, next question. ABCD is a quadrilateral. AD is equal to AB. Okay, so put that on the diagram. Okay, make sure you're adding things to the diagram because they won't put things on there. AD, sorry, that one is equal to AB. CD is equal to CB. So, the ones that are the same, you put one line through, and then if you've got other lines that are the same, you put another line through. Okay, prove that angle ADC, so ADC is equal to angle ABC. Right, actually, I've just remembered, I need to go back to this question, because I didn't answer it fully. It was a very similar layout to this one, so actually it was this question here, to prove that AC equals BD. I put they're congruent, I need to just say, well, because they're congruent now, AC is equal to BD. As the triangles are congruent, make sure to answer the question. Side AC is equal to side BD. So I'll prove they're congruent, but that wasn't the question. I've fallen into one of the traps there, basically answering the question I wanted it to be. I know it's about that, but yeah, I've conflated the two things and just thought that was enough, or forgotten about the question really. So make sure to reread the question after you've done it, is a good suggestion. Prove that angle ADC to ADC, prove that this angle is equal to angle ABC. Well, if they are the same, they're congruent triangles, then that will be the case. So, if I can prove, drawing the straight line here, the reason I've done that is because this is kind of a common shape, or relatively common with congruent triangles. You want to split it up into two triangles. If these are congruent triangles, these two, and that angle must be the same. That's what it means if they're congruent, the angles are the same, sides are the same, corresponding ones. So, let's start writing this. First bullet point, side AD is equal to side AB. That's given, so I don't need to explain that. Side DC is equal to side BC. Again, that's given in the question. Side AC is a common side. Therefore, triangle ADC is congruent to triangle ABC by side, side, side. As the triangles are congruent, angle ADC is equal to angle ABC, and then we're done. Right, next question. Prove that triangle ABC is congruent to triangle ACD. So prove that triangle ABC is congruent to triangle ACD. I'll give you a second to think about that while I have a drink again. Now they could all have the same angles, but we don't know the numbers for any of these sides. That's fine, you just need to, in that case, find that one of the sides is the same length, don't you? As, you know, the other triangle. Because you can't just have angle, 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 because then it could be an enlargement. So we need to have at least one side that is the same. Okay. Now, I'll do this angle first of all. It's got to be the same because the other two angles are the same in that triangle. We'll do 180, take away 80, take away 56 is 44 degrees. Write that on the diagram. Okay, then we've got side AC is shared, okay? So, although we don't know how, you know, the length of it, we don't know what size it is, we know that for triangle ABC and triangle ACD, it has to be the same length, okay, because it's a shared side. Now we just need to write down the points and finish and do the proof basically. We've got angle, side, angle. We don't need to worry about this opposite angle over here. So, where should we start? Angle BAC is equal to angle, sorry, that shouldn't be 44, should it? That should be 56, because that one's 44 over there, is equal to angle ACD. Next point, let's go with angle BCA, that's equal to angle DAC. Next point is side AC is a shared side. Therefore, triangles ABC and ACD are congruent by angle side angle. Okay, that's finished now, all sorted. Right. Next questions. These are the ones which are the trickier ones, and probably the trickiest ones I could find. And these are from GCSE Maths questions. So if you wanted to go back through and look at the answers again, they're on there. So A, B, C, and D are 4 points on a circle. Right. So straight away, what I'm thinking actually is circle theorems as well. So I'm going to probably want to show that some of these angles are the same using my circle theorems. AEC and DEB. So AEC and DEB are straight lines. Okay. Right, now that straight away means that these angles here have to be the same, okay, because they're vertically opposite angles. Triangle AED, so AED is an equilateral triangle, which means that that's 60 degrees. Now angles on a straight line means that that's 120 degrees, which means that's 120, which means that is 60 degrees. Now that probably is important because they've told us it's an equilateral triangle, which also means that's 60, which means that's 60, which means all of those lengths, that is the same as that, is the same as that, and that is the same as that, is the same as that. So I can start putting on all my side lengths. Prove that triangle ABC, so ABC, is congruent to triangle DCB. So I'm looking at this triangle here. I'll try and go over it in my ruler to just identify. You might want to do this with a highlighter in the exam. Just go over it so we can see actually which triangles we're looking at. We're looking at this one. So ACB. And then I'll change the colour of the pen to make it a bit easier to see. We're looking at ACB. So I want to show those are the same. Now we've got a shared side straight away. So I'll start writing it down actually, because that's going to be a key point. BC is a shared side. So we've got that first of all. We've also got, I haven't written on, sorry, the rest of these angles here, that's got to be 60, that's got to be 60 in that triangle because it's equilateral. Well, it's got to be equilateral, hasn't it? Because it told us that they're straight lines, that's 60. AED is an equilateral triangle. Yeah, that's 120, that's 120, that's 60. The other thing we've got, if that's 60, that's 120. Right. Okay. So, equilateral triangle, that's 60 as well. Just thinking, could I have been sure that they are the same? And how could I be sure they're the same? Right. We have got as well, what we need to do is work out this angle up here, or we could work out that angle. We should show these triangles are congruent. We've got that side shared. We've got that this side is, well, it has to be, if that's the same, then that side has to be the same as this one. So, what does it tell us again? AEC, and DEB are straight lines. Right, they're straight lines. Okay, they're straight lines, they cross at a point. We've got a cyclic or cyclic quadrilateral in here, haven't we? AED is an equilateral triangle, AED. So that's 60, that's 120, that's definitely true, that has to be 60. Now, why are those three the same? That's got to be equal, okay. But how do those angles have to be 60? Thinking about that, we have got, and you want to probably think about your circle theorems now. Sometimes it'll be a bit different with the orientation, which is why I'm angling my head a little bit here. Okay, so we do have, actually, we do know, because actually I'm just going to get rid of these bits because I can't be 100% sure about those. I just want to get rid of those. There probably is a reason, but as yet I can't think of it. I'm looking at angles subtended from the same chord, basically. So, angles subtended from the same chord. Now, this is a chord here, so this angle and this angle have to be the same. Okay. I've also got angles from this chord. This angle has to be the same as this angle. Okay, now what we've got, I've got three angles in both triangles. Sorry, not three angles, sorry. I've got, in this blue triangle, I've got that angle the same as that angle. So they're the same. I've got that BC is a shared side. I've got that, well, I've got one angle and I've got a shared side at the moment. So, right, I can see it now. And this is sometimes a tricky bit. If you think about DC as this chord, okay, so it's gone from DC, and this is again angles subtended from the same chord, it's gone from DC to a point on the circle, okay, but I can also go from DC and go to this point, so that does have to be 60, and that side has to be the same because this also has to be 60. So going from DC, so angles subtended from the same chord are equal, so going from DC to here, or I can go from there to that point, so that's angles subtended from the same chord are equal. It's basically, it's easier to see usually if I just do a quick sketch. If you have something like this, that angle is equal to that angle, and that one's equal to that, and they're equal there. Yeah, so that one, those are equal, those are equal. So that has to be equal to that, which is 60, and by the same token, if I go from AB, that angle has to be equal to that angle, and these two end up being similar shapes. So that is an equilateral triangle, which means we've then got BC as a shared side, and we can basically use anything now, any of these reasons, because we can use that, because that is equal to this, same side, add the same length side, has to be the same length. So, side, let's go with BD, sorry, is equal to side, what was it, AC. And then we've got two sides, so we've got that side and this side, and we've got shared side and this side. So we've got two sides that are the same, so we need the side now, so the angle in between those two sides, which is 60. So angle DBC is equal to angle, so DBC, that is equal to angle ACB. Again, it might be beneficial to draw these triangles out again. I'll try and draw them a bit better this time. So that's like one of them, and the other one is going the other way, isn't it? So it's going, so we've got this, and it's going off this way. Okay, and we've got 60 degrees in there, that's a shared side. And then we've also got that other side there. I haven't drawn my triangle quite right. this side is also the same. Okay, that's 60 in here. You can see a bit better there. Therefore, triangle BCD, put the letters in order, is congruent to triangle ABC by, what have we got? We've got side, or side angle side by side angle side. Okay, super. Now what I'm going to do, because of time, I'm going to leave this question for you to try at home. Prove that triangle ADP, so I'll draw it on for you so you can see which triangles it's talking about. So ADP is congruent to triangle CBQ, so this one here. Now the key with this question is the parallel lines. Actually, do you know what? I'll go through this question because you're probably wondering otherwise, and this is the whole point of these sessions. So, ABCD is a parallelogram. So that is ABCD is a parallelogram. Okay. Right. That's useful to know. That means that this angle here, so the parallelogram is ABCD. It's basically red line, and then A to B, that blue line, and then across to D. We know that opposite angles of a parallelogram are equal, so that angle has to be equal to this one. They're the same, and also this one has to be equal to this one. So if that whole angle, so if the whole thing is the same, because they're opposite angles, that means that blue bit that I drew at first must be the same. So they're the same, because it's just the angle take 90, angle take 90. Right, ABP and QBC are straight lines, okay, that will help. Prove that triangle, angle ADP is a right angle, and angle CBQ is a right angle. Okay, what I'm going to do, I'm going to sketch these triangles out again, just to give me a bit of help. It's a sketch, doesn't have to be perfect. Right angle in there, that is QBC. I want to do the other one, I'll do it in red, because I went over it in red. So, need a line going along this way. Right angle's at the bottom down here, so I'll go down like that, and then go up again. And again, one of them always seems to be bigger than the other one, but it's a sketch, it's not supposed to be perfect. So that's ADP. We've got parallel lines here as well. We also know that that must be parallel to that, to make your parallelogram. Prove that triangle ADP is congruent to triangle CBQ. We've got a right angle. Now, we know that, also put the other angle on. So this angle here, that is equal to this angle here. Now if it's a parallelogram, then the sides have to be equal length, because it's a rectangle pushed over. So actually AD has to be equal to BC. So then we've got angle, side, angle, which is sufficient for congruent triangles. Okay, so that used parallelogram facts in there as well as, you know, corresponding or parallel line facts corresponding co-interior. You might want to use co-interior angles to work that out. Okay, so just formulate that now. Write down our answer. So angle QBC is equal to angle PDA. That's given in the question. side BC is equal to side AD as angles, as opposite sides of a parallelogram are equal. And third bullet point, angle BCQ is equal to angle DAP as opposite angles in a parallelogram are equal. Therefore, I'll have to do the bullet point down here. Hopefully you can still see this. Hi Noah. Ah yes, Lewis, you got it. You got it before me. Well done. So, well, probably before me, I expect anyway. What was I saying? Last bullet point. Therefore, triangles. What is it? ADP and QBC or CBQ are congruent. Okay. Right. That's that one done. That's one of the harder ones of seeing them, but it's harder because these parallelogram facts, opposite angles of a parallelogram are equal. One thing to say, you don't have to draw the sketches, but maybe highlighting the triangles makes things easier. But when it's got a lot of lines on there like this or like this, it can be quite confusing. Make sure you get on the information that you need, and maybe draw the triangles out if that helps. Label the corners as well, because if you don't label the corners, it's going to get really confusing. Okay, now I just wanted to show you this from Maths Genie. Now this has got, I can't really show you all of it because of the ways it's printed out, but this has got loads of questions on it on congruent triangles. I haven't used any of these, so you could go away and try them. I know some students that I've taught have used them before. Okay, and that one does have a right angle there, so then you can do it the way we spoke about earlier. Okay, and they are quite similar, some of those, to the ones we've done today. This one, the one that I put in the what is it called? The picture for the video. You know what I'm talking about. How or prove that this triangle is congruent. Is it congruent? Is it not? Can you prove it? Well, vertically opposite angles. Those angles have to be the same. Okay, so first thing to write is angle BCA is equal to angle DCE. You might want to write as vertically opposite angles are equal. It's always better to give more information than worry about is it enough. So if you are unsure, put a bit more down like that, put your reason down. Okay. Now the key thing is these are parallel lines. So we've then got, because they're parallel lines, this angle here must be equal to this angle here because they're alternate angles. So they've got to be equal, and also by the same token, these are equal here because alternate angles are equal. So we've now got three angles in a side, so actually I didn't need to write down this bullet point, but it doesn't matter. Angle ABC is equal to angle this one, so that is going to be EDC as alternate angles are equal. And the last one, angle, which one I'm doing now, BAC is equal to angle, so BAC, this one is equal to this one, so that's AED, or actually CED, I should do, to keep them as two separate triangles, as alternate angles are equal. Therefore, triangles ABC and CDE, we'll keep the letters in order, all that it matters, are congruent by, well, angle, side, angle. Even though I wrote down that that angle was the same at the start, but it doesn't matter. Okay, so that's how you do it. Right, that's all the questions I have got to go through. That's well over an hour now. I always seem to go over. Yes, good luck with your revision. You know, keep working hard. Like I said at the start, it will pay off. It will make a difference. Watching these sessions, you know, will help as well. You know, if you know the content, that's brilliant. But this will also help with exam technique and the way you're thinking and doing things and formulating things and answering questions. That will all help. Okay, right. Yeah, I'll see you at the same time next Sunday, 10:30. If you've got any suggestions, put them in the comments because I've got no idea what we're going to do yet. Otherwise, I'll have to pick a topic out of thin air and think about probably which is one of the trickier topics that we haven't done so far. Okay, right. See you next week, people. Bye-bye.